This is section 5.6, and we're going to focus on logarithmic and exponential equations. So we've learned the information about logs and exponents. We're just going to practice more on solving those equations. And I've just put three things here to remind you. We've talked about this. This is going from log form to exponential form. And so you need to be able to do that. You need to be able to go from a log form to exponential in order to solve sometimes. If you have two log statements and you've set them equal, if the bases are the same, then these two arguments will have to be the same. If you have an exponential statement where you've got two bases, they're the same, then if you can get rid of the bases and the exponents have to be equal. So let's look at some examples. So log base 4 of x equals 2. We're going to switch to exponential. Remember, that's our strategy. Here's your base, here's your exponent. 4 squared equals x. 16 equals x, so you have solved. Same thing here. Base is 2, exponent's 4. 2 to the 4th equals 5x. 16 is 5x. Divide by your 5, so 16 over 5 is equal to x. Now here, we've got that log statement where two logs are equal, bases are the same. We can drop this, the log and the base, and just say, well, the arguments have to be equal. So x plus 2 has to equal 8, x has to be 6. Over here, same idea. We get to drop the log and the base because they're the same. 2x plus 3 has to equal 3. Ultimately, x is 0. Then if we're doing this one, we can't change to exponential until we have one log. So we use the properties of logs, and we're going to first put the powers up. So that 3 goes there. That's what I did there. Then we're going to say this is a addition, so we're going to make it a product. So log base 2 of 4 times x minus 1 to the third power. All right, so then we can change to exponential. 2 to the 5th equals 4 times this cubed. That makes that 32. That's all I did in that line. Then I divided the 4 over here, so now I have 8 equals this to the third power. I can't do anything with this with it being raised to the third, so I'm going to take the cube root of both sides. That will get that out of the cubic. So cube root of that, cube root of 8. The cube root of 8 is 2. You're just left with the x minus 1, so you add 1 over there, and x is 3. All right. Same thing with this one, but one thing that I wanted you to note, we didn't have to worry about that here. 3 minus 1 is 2, so you didn't have a problem here. I didn't say checking that, but we don't have a problem. We don't get a negative or anything there. But here, we need to look at what the domain restrictions are on these. X has to be greater than -7, because I can't have, I've got to have a positive argument. And x can't be greater than -8. So I know that going in. I want to make note of that. Then I do the combination. So I have log base 2 of that product. I go ahead and FOIL that out. I subtract the 1. Oh, no, I'm not subtracting 1, so sorry. 2 is the base, and it's going to be raised to the 1 power. So 2 to the 1 is 0, equals this. And then, I'm sorry, I just went right here. So 2 to the first is 2. But when I want to make this equal to 0, I'm going to subtract the 2, and I get 54. So then I can factor 6 and 9 give me 54 as a product, and they add to be 15. And I get -6 and -9. But we have to think about what we said our restrictions were. We have to be greater than -7 or greater than -8. -9 is not greater than that. So we're going to have to discard that one. It's less than -8 and -7. All right, exponential ones. Remember, we can try to make the bases be the same on this. So I rewrite 8 as 2 cubed. If I get that, the bases can leave, and I have x plus 5 equals 3, x is negative 2. And we just did this in the last section, I believe, but we have 2 to the x equals 10. We can't make the bases be the same, so we're going to look for this rule here. We're going to take the natural log of both sides. That's our first step. Then this power can come to the front. I've got x ln 2 equals ln 10. This is just a number, so I'm going to divide both sides by that number. So x is ln 10 over ln 2. That's the exact form of the answer, or you do it in the calculator and you get a decimal. All right. This one is the same. We can't make the bases be the same. Excuse me. So we're going to take the natural log of both sides. That negative x is going to come to the front. Then we're going to divide by the ln 8. And then we've got negative x, so I need to divide by negative 1. And that's what I get, or the decimal version. So I think that's a recap of the different kinds of problems we'll look at. And so let's go actually look at our problem. All right, so number 1 says solve by using the quadratic formula. This is just a reminder of solving, and it doesn't have a log, doesn't have an exponential, but for quadratic formula is here. You had to know that A is 1, that's the number there, B is negative 6, C is negative 16. And we go in and we plug in all the numbers, we work through it, and we get x is 6 plus or minus 10 over 2. So that means you could have 6 plus 10 is 16 divided by 2. That gives you 8. 6 minus 10 is a negative 4. That's going to give you a negative 2. So that was just a practice. Now, you could also approximate solutions to this using a graphing utility. This is a reminder as well. We threw this in y1 and y2 to be 0, and this is where it crosses. So this is giving you the real solution. Right here you can do second calc and choose intersection, and you can get that number, and it says round to the 100th. Be sure you watch that. All right, so those were 2 other kinds of equations. Just a reminder, a refresher. Let's now look at our log ones. We looked at one like this in our example. Log base 4 of x equals 2. Base to exponent equals argument. Base to exponent. So 4 squared is 16. All right. Base to exponent equals argument. 2 to the second power. Base to exponent equals 7x. 4 is 7x. Divide by 7, so 4 over 7 is equal to x. Another logarithmic. Log base 5 of this equals 3. Base is 5, exponent 3. There's your argument. 5 cubed is 125. You're going to add 8 to that, and then you're going to divide by 3 and leave it in a fraction form. Here we have 2 log expressions, same base, so we can drop them. I've worked it out a long way, but you know, as we said, you can drop that and you could have x plus 3 equals 11. If you did it the long way, that's where we subtracted one of the logs and then we have it equal to 0, and then we turn it into a log exponential expression. So we have log base 9 of x plus 3 over 11. And then we say 9 to the 0 power equals this. 1 equals this. Multiply 11. This was much longer in 8. So if we use that rule that we looked at in the first thing, that's really a better way to solve that. All right. On this one, the understood base here is 10. It's not written there, but we're going to combine these two. So we have log base 10 of x times x minus 99 equals 2. So base to exponent, 10 squared equals x squared minus 99x. That's 100. we're going to subtract that 100 over here. So now I've just got a quadratic. 0 equals this. I can factor 100 and 1. 100 times 1 gives me 100, and I can get 99 for the middle number, and I get 100 and negative 1. You cannot use the negative 1 because right here and here, it gives you a negative, and you cannot take the log of that in the original. So we discard that one. Be sure you watch that. Same thing with number 8. I'm not going to go through every step of that, but it is just like that one up there. You create a product, then you turn it into exponential, and then you factor and check your answers to make sure that when you plug it in here or here, you don't get a negative, which we do. So one of those got discarded. Number 9, we're back at exponential. So we have 8 to the x minus 5, and then change 64 to 8 squared. Once you do that, the bases are the same. You get rid of them. You have x minus 5 equals 2, and x equals 7. 7 to the x equals 8. There's no changing to get same bases, so we're going to take the natural log of both sides. The x gets to come to the front, so we have x ln 7 equals ln 8. Divide by the ln 7. And this says type an exact answer. Type an exact answer. Let me do that, because that means leave it in ln form. Don't use your calculator. All right, 5 to the 1 minus 2x equals 2x. All right, so we're going to take the natural log of both sides. That's our first thing. Then this exponent comes to the front. Did that. Because I've got x's on both sides, I need to go ahead and do this distributing. So if I distribute that ln 5 to both those pieces, I get ln 5 minus 2x ln 5 equals ln 2x. This one's a little bit more involved. Now we got to get the x's on one side. So I'm going to add that piece over here. Okay. Then I need to just solve for x. So I'm going to factor out x out of this thing. And when I pull x out of this, I get x is on the outside. I get ln 2 because I pulled out x. Over here, if I pull out x, I'm left with 2 ln 5. Then I'm going to divide all of this to the other side, and that gives me what x is. And again, it wants an exact answer, so that means we're going to leave it in ln form. All right, number 12. And we don't want to get frightened when we see pi and e and weird things. Those are just numbers. They're just numbers. So we have pi to the 1 minus x equals e to the 2x. All right? So we're going to take the natural log of both sides. And over here, we have to remember the rule. ln of e to anything is the anything. So that piece becomes 2x. Now I'm going to distribute the ln pi to both these. So I have ln pi minus x ln pi equals 2x. All right? So now I've got an x term here and an x term here. So I'm going to add this guy to the other side. I want all the things that have x in it. I'm going to pull out the x. So I'm left with a 2 and an ln pi right there. I'm going to divide this expression to the other side, and I am done with that one. And once again, exact answer, and you can leave pi in it if you need to, which we are doing. Okay, so I think that is all. We have 12 questions, so they should be good, and that should get you through 5, 6.